All right, this one's a little evil. 80 foot, do we deal in feet? Say no. And rotates once every 24 seconds, so that's my period. I bet I'm going to have to solve for velocity here. We know that because they gave us period. T is period, right? Time it takes to go around once. So let's do some converting. 80 feet, feet bad, meter good. 1 foot is how much of a meter? When I Googled feet to meter, I got 0.3048 meters equals 1 foot. Feet goes away, so it's 80 times 0.3048. And I get 24.4. meters. But careful, this is diameter. So let's divide by 2 to get radius. So let's call this 12.2 meters equals radius. So I have radius. I probably, just kind of a hint here, you probably need velocity at this point. I have mass, that's okay. So velocity equals 2 pi r over period. That was just an equation. It's basically velocity equals distance over time. And so 2 pi times the radius, didn't we just do that? 12.2 meters. And the period we said was 24 seconds. So to the calculator I go. And I get a velocity of 3.19. I don't know why I didn't go to 3.2, but that's my velocity. All right, now I should be able to do this. I've got all my kind of ickiness worked out. So lowest point of the circle is going to be, let's call that A, since they're calling it A. Lowest point of the circle is here, force gravity is down, force normal is up. And I'm solving for apparent weight is secret physics code for force normal, and the center of the circle is up. So sum of the forces in the direction it's accelerating is mv squared over r. My forces are force normal is positive, force gravity is negative, equals mv squared over r. So basically I'm going to get force normal equals mv squared over r. Then I have to add force gravity to that. And I can probably start putting in some numbers here, yes? Mass is 70 kilograms. V, didn't we do that like an hour ago? 3.19 meters per second. I have to square that entire quantity. And radius, we did that a while back. And whatever that number is, I have to add force gravity. Force gravity is just mass times gravity. So 70 times 9.8. You should 686 newtons. And let's do this first number first, 3.19. I'm going to square it. I'm going to times that by 70 and divide by 12.2, and I get 58.4 newtons plus 686 newtons, and I get a force normal equaling 744. And we talked about this in class. It should be bigger at the bottom than the top. All right, now we're at the top. I guess this is a loop-to-loop one, yes? So force normal is down, force gravity is down, and my acceleration is down. So everything's going to be positive. And some of the forces that are accelerating or going around the circle. And I have a force normal, which is positive, and a force gravity, which is positive, equals mv squared over r. This is newtons, so force normal equals mv squared over r minus my force gravity. And didn't we just do this number before? Well, I'll do it again for you, I guess. What was our mass? Wasn't our mass 70 or something? Yeah, 70 kilograms. V is 3.9 meters per second. Whoops. And I have to square that. That's what I was trying to do there. And my radius, I thought, was 12.2. But now I'm going to subtract off my mass. Not my mass, my weight. And wasn't that 686 newtons before? So, force normal equals, I should have that number in there. Isn't that just 58? 3.19. It's not in my calculator anymore. Times 70 divided by 12.2. Yes, it's 58. 58.4 newtons. That's this number here. And now I have to subtract off the 686 newtons. So we're getting force normal of, what's that come out to? About 627, 628. Now, you might see that that's negative, and again, remember we kind of have to play some games with the direction. Basically, if you think about this, this negative means it's in the same direction of gravity normally, because we played games with the weight being positive, negative. So it still works. You got to play games along the way or at the end, and this being at the end, it's still okay. Force normal is 628, if you just want to think of it that way, pointed in the direction down. And again, with the gravity and 9.8, you just, again, you play the game along the way or at the end, and this way we'll just, the direction's right, it's still down. And our numbers are right, our magnitudes are right, so don't worry about it, it still works. Again, it's just a direction thing. Woo!